Welcome to Python, Predicting House Prices. In this lesson, we will explore how to predict house prices using Python. You will learn by doing, step by step, as an absolute beginner. By the end, you will have built a simple house price predictor. Running the cell now. Let us get started. Like the video if you are excited to learn. What does predicting mean in Python? Predicting means using information you have to make a guess about something unknown. In our case, we will guess a house's price based on its features. Running the cell now. Let us warm up with a simple print statement. Comments start with a hash symbol and help describe code. This prints a message welcoming you to the project. Running the cell now. Try printing your own welcome message below. Variables hold important information. Here we are making variables for the number of rooms, the house size, and the city. Num_rooms is how many rooms the house has. House_size is in square feet. City is just a name of a place. Running the cell now. Can you make your own variables for a fictional house? Let us interact with the user by asking questions. Adding comments reminds us what the section is for. This line asks for the number of rooms and waits for the user to type it. This line asks for the size of the house and waits too. This line shows both answers at once. Running the cell now. Try different answers each time you run it. Why are variables useful for prediction? Variables help us remember and organize information. Imagine keeping all the details of many houses in your head, it would get confusing fast. Python does that for us. Running the cell now. Now, we organize house info using a dictionary. This comment reminds us what we are doing. We create a dictionary that stores all the house info together. It keeps track of the number of rooms. It saves the size in square feet. It adds the city. And we can store the price. Showing what our dictionary looks like. Running the cell now. Try adding another property to the dictionary next. Let us see how to look up details in a dictionary. The comment suggests we will grab info from the dictionary. This shows how many rooms the house has. Here we print the price. And this prints the city. Running the cell now. Practice, change a value in the dictionary, then print it. What if the data is not in the dictionary? The comment warns us about possible missing data. Using get helps us avoid errors and gives a friendly message if something is not found. Running the cell now. See if you can add a garage entry to the dictionary. Updating our data, the house gets a new room. Let's change our house dictionary to reflect a renovation and update the price. Running the cell now. Let us update our house with a new room. These comments tell us we will change the number of rooms and price. Adding 1 to the number of rooms. Raising the price because the house is bigger. The print statement lets us see the changes. Running the cell now. Try adding another feature, like pool, true. What if we need to remove outdated information? The comment prepares us for deleting an entry. We delete the city value from our data. The dictionary now shows the update. Running the cell now. Practice removing or adding a new key to the house dictionary. Let us see what keys and values our dictionary has. Built-in methods save us time and work. Keys gives us a list of the attribute names in the house. Values gives us only the data for each attribute. Running the cell now. Try running house.items to see both at once. How do we manage lots of houses? Now, we use a list to store dictionaries, each one is a different house. The opening bracket starts the list. This dictionary is for a small house. This one is for a big house. And this is a medium-sized house. The list closes here. Printing shows all the houses at once. Running the cell now. Try adding a house with a different number of rooms. Let us look at each house in the list. Using a loop helps us work with many houses easily. This tells Python to look at every house one at a time. Here, we print the number of rooms and the price for each house. Running the cell now. Practice, try printing size 2. Here is a fast way to pull all prices using list comprehension. List comprehensions are a quick way to make new lists. This line collects every price into a new list called prices. We print the prices to check the result. Running the cell now. Practice, try making a list of all the house sizes. How do we find just expensive houses? We are picking only houses above $200,000 using a filter. This collects those houses into a new list. Printing helps us see if our filter worked. Running the cell now. Try changing the price to filter for cheaper houses. Next, let us sort the houses by price. Sorting can help us spot the cheapest or most expensive house quickly. This uses sorted to make a new list from cheapest to priciest. We show the sorted result to check the order. Running the cell now. Challenge, try sorting by size instead of price. Combining features helps us compare houses fairly. We loop through each house. Calculating the price divided by the size gives us cost per square foot. The round function keeps the result tidy with 2 decimals. Print shows us the cost for each house. Running the cell now. See if you can print which house is the best deal. Real data. Let's set up a tiny dataset to predict house prices. We will model price as price equals 50,000 plus rooms asterisk 30,000 plus size asterisk 120. This is a formula based on real-life guesswork. Running the cell now. Let us try the formula with some example numbers. We use sample numbers for rooms and size. Assigning 3 for the number of rooms. Setting the size to 1,600 square feet. We plug the numbers into the formula for our prediction. Print lets us see the predicted price. Running the cell now. Practice, change the room or size value and see what happens. Let us build a mini predictor you can run yourself. This cell lets you type in your house's features. We ask for rooms, making sure the answer is a number. We ask for the size, also as a number. The formula predicts the price using your inputs. Print shows your house price guess right away. Running the cell now. Mini project part 1, predict several house prices at once. Imagine you are predicting prices for 3 houses, 2 rooms, 900 square feet, 4 rooms, 2,100 square feet, and 5 rooms, 2,500 square feet. Let's code this with a loop. Running the cell now. Let us solve for several houses at once. First, we make a list of tuples for rooms and size. This line starts the list. First house, 2 rooms, 900 square feet. Second, for rooms, 2,100 square feet. Third, 5 rooms, 2,500 square feet. Loop through each house, pulling rooms and size. Use the formula to get the price prediction. Print each price as we go. Running the cell now. Try using different numbers for practice. Let us turn our formula into a reusable function. A function lets us reuse our prediction formula anytime. We give it 2 inputs, rooms and size. It returns the predicted price. Now, we easily get the price for a new house by calling the function. Running the cell now. Can you write a function for price per square foot too? It is smart to check that the data is correct before predicting. This function checks your input before running the formula. If either piece of info is not a whole number, it warns the user. We check the type for rooms. We check for size too. If the check fails, it prints a friendly message and stops. If all is fine, the function returns the price. Example, giving words instead of numbers returns a warning. If both pieces are numbers, the function works as expected. Running the cell now. Practice making your own safety checks in a function. Let us handle little mistakes so our code does not crash. Try and accept our tools for catching errors. Trying to predict with a word, will cause trouble. Inside try, Python tries the risky code. If there is a mistake, except catches it. The print statement gives us a friendly error message. We can see what went wrong. Running the cell now. Try using a number instead and see if the error goes away. Let us make our code more flexible for real-world data. We combine lists and dictionaries to store more details. We give each house an ID and a city name. More rows can be added for extra houses. Looping through, we predict and store the price for each house. We add the prediction into the house's dictionary. Now, every house has its own data and price. Running the cell now. Try changing the city and see how the data displays differently. Here is a challenge to wrap up. Add your own info. We invite the user to enter their house details. First we ask for number of rooms. Then, we ask about size. Now city name. We create a new dictionary entry for your house. The ID gets a number so each entry is unique. Rooms go in as you typed. Size is added. City is saved. We predict the price just like before. Now we add your house to the group. Printing shows the updated list with your data. Running the cell now. Do you see your info in the list? Try different numbers and city names. Like this video if you found it helpful. Share and subscribe for more beginner Python lessons. Extra mini project, compare all house prices and show the best deal. Using our dataset, let's find the house with the lowest price per square foot. Running the cell now. Let us find out which house gives us the best value. We start with empty placeholders for the winner. The ID is empty to start. Best value is empty too. Loop through every house in our dataset. Divide price by size to get the cost per square foot. If we have not found a value yet or this one is better, update our best. Store this new best value. Keep track of the best house's ID. Final print shows which house is the best deal and its price per square foot. Running the cell now. Try changing the dataset and see if a different house wins. Recap, what have you learned? Variables and dictionaries help organize data. Lists let us store many houses. Loops let us process data quickly. Functions are reusable calculation tools. Safety checks and try except keep things friendly. Now you can predict house prices and find bargains like a pro. Running the cell now. Thanks for learning with us. If you enjoyed this, please like, comment and subscribe to our YouTube channel. Share this lesson with friends who want to learn Python, too. Happy coding! Running the cell now.